Hello everyone, I am Praveen BR, Assistant Professor, Department of Electrical and Electronics Engineering from Sai Vidya Institute of Technology, welcoming you all to the Microcontroller Lab programs. Here I'll be teaching the Microcontroller Lab programs for 5th semester electrical students of 2017 and 2018 scheme. The subject code is 18EEL57. So let us study the next program for microcontroller, that is writing an assembly language program to subtract a multi-byte number in two memory location, one which is there in 8000H memory location and the another number which is there in 9000H memory location, and the resultant will be stored in 6000H memory location. So to do this, we'll use the software called as Keel Microvision. In this Keel Microvision software, let us see how to perform the program. So the first step in the Keel Microvision software is, in the menu bar, go to the fourth tab, select project. In the project tab, select new Microvision project. In the new Microvision project, click or write the file name as subtraction, because we are performing subtraction operation. So write the file name as subtraction and click on save. It will ask us to choose the Atmel microchip. So in the search, type as AT89C51ED2. This is the microchip which we are using for performing the execution of the program in the Keel Microvision for 8051 programming. So choose AT89C51 ED2 and press OK and press No. The target gets created. After the target is created, next we have to type the program. To type the program, the editor window has to be enabled. The editor window can be enabled by going to the menu. In the menu, choose File. In the file, choose New. The editor window gets enabled. Type the program in the editor window by typing the program for subtraction. After typing, we have to save the program. The program can be saved by going again to File. In the File menu, you will go to Save As. It will ask for the extension file. So you give this as subtraction.asm. ASM indicates that we are following assembly language program. So you click Save. After this, now in the project window, you are going to right click on target 1. You choose options for target 1. You have to apply or you have to enter the crystal frequency. By default, it would be 33.0. You have to enter 11.0591 megahertz. In the same window, go to the output tab. The create hex file will be unchecked. You have to check the create hex file and then press OK. Now you have to add this file to the project. You have to expand target 1 in the project window. Right click on source group 1. Go to add existing file. Choose subtraction.asm. Choose subtraction.asm and press add button and press close. So your file has been added to the project. Now we have to do the compilation. Compilation has 3 steps. What do? We check for the errors. How do we check for the errors? First, we are going to translate and see in the build output window whether there are any errors. If it indicates 0 errors and 0 warning, it means that there are no errors. I press build, it links to the hex file. Then I press rebuild, which completes the compilation. After this is done, go to the debug in the file menu, or in the menu, go to debug, choose start stop debug session. A window appears, press OK. You will be led to the output window. In the output window, again, go to view. You can find here that there are different tabs. Memory 1, which is indicating 8000H memory location. Again, go to the view tab. In the view tab, choose memory window. Under memory window, choose memory 2. Again, go to view. Go to memory window. Choose memory 3. So 2 windows are for keying the input, and the third window is for checking the output. Now let us go to the inputting the data in the program. Let me enter the numbers. I give in 8000 data as AA. In 8001, I give data as BB. In 8002, I give data as CC. And in 8003, I give the data as DD. So AA, BB, CC, DD is a 64-bit data I'm considering. Another 64-bit data is taken in memory window 2. So I consider in memory window 2 in 9000H memory location 01. I take the second data 02. I take the third data 03 and the fourth data 04. Now in 6000H before execution, all the data will be 0. This is where you're going to check the output. So let us see how to do the execution. Since I'm taking a 64-bit data, I divide the 64-bit data option into 4 groups. At a time, 2 8-bit data are going to be subtracted. If it is a 16-bit operation, 2 times it is going to be taken, and if it is 8-bit operation, 1 time it is going to be subtracted. So the count value here indicates that how many times you're performing the operation. So here I'm going to give R7 as 04, which indicates that I'm considered a 64-bit number. Now the source addresses are stored in different registers. 8000 and 9000 are the source registers, which are stored in register R2, R3, R4, R5. So I store 80 and 00 in register R2 and R3, and I store 90 and 00 in register R4 and R5, and the destination is 60 and 00, that is 6000. I store it in R0 and R6. Before I perform the operation, I'm going to clear the contents of the carry. So I'm going to clear the contents of the carry. Now it has to point towards the first data. My first data should be present in 9000H memory location. 90 is present in R4 and 00 is present in R5. So my data pointer should be pointing towards 9000. So it is pointed with the help of DPH and DPL. So the data present in R4 will be brought to DPH. So data present in R4 is 90, which is brought to DPH. And the data present in R5 is 00, which is brought to DPL. Therefore, your data pointer will be pointing towards 9000 memory location. The data present in 9000 memory location is 01. Now, I will bring 01 to the accumulator with the help of the data move x a comma at the rate of dptr. This instruction will move the data from 9000H memory location to accumulator. the data present in the accumulator will be moved to register R1 because I have to fetch the second data. So to fetch the second data, external memory is required, and to take the data from the external memory, accumulator is going to be used. Hence, the data present in the accumulator will be moved to one of the registers. So R1 is used here. Next, we are going to take the next data. So before we take the next data, your register, your data pointer will be incremented. The data present in the data pointer 90 and 01 will be stored back to R4 and R5 for further use. Now I have to take the second number. The second number is stored in 8000 memory location. So 80 is stored in R2 and 00 is stored in R3. So your data pointer should point towards 8000H memory location. So it points towards 8000H memory location. The data present in 8000H memory location is AA, which is brought to accumulator. So when I say move x a comma at the rate of dptr, the data present in 8000H will be brought to accumulator. So AA will be brought to accumulator. So now I will increment the the data pointer content, and I'm going to do the subtraction. Subtraction of what? Subtraction of the data present in the accumulator with the data present in the register R1 and subtract it with the data present in the carry. So the data present in the accumulator is AA. Data present in R1 is 01. So AA minus 01 is A9. A9 minus 0 is A9 again. So the answer is A9. This has to be stored in 6000 memory location. 60 is stored in R0 and 00 is stored in 00 in register R6. So your data pointer will be pointing towards 6000 memory location. Now I store the data that is present in the accumulator in the memory location 6000 by using the instruction move x at the rate of dptr, comma a. So this instruction will store the answer A9 in 6000H memory location. So I have performed one subtraction operation of two 8-bit numbers. Like this, I have to perform for two more. So now I increment the destination address. That is, I increment 6000 to 6001. I store 60 in register R0 and 00 in register R6. Now I check whether I have completed the operation. I decrement the data present in R7 by 1 time, so it becomes 3. I compare 3 whether it is equal to 0. When it is not equal to 0, again it performs the operation. Now BB will be subtracted with 2. So BB is subtracted with 2, and subtraction of BB and 2, you will get the answer as B9. B9 will be stored in 6001 memory location. Again, it gets incremented to 6002. Now, again the data will be fetched from 9000H, that is 03 data will be taken. CC will be subtracted with 03. CC minus 03 is C9. C9 will be stored in 6002 memory location. Again, we are going to see the fourth data, that is 04 is taken. 04 will be subtracted with DD. So DD minus 04 is D9. D9 will be stored in 6003 memory location. So this is how subtraction takes place in Keel Microvision software. And this is for a 64-bit subtraction. Thank you for watching this video.